Everyone, welcome back from the break. We're now going to go through and talk a little bit about the final exam and review some of the methods that we covered earlier. So I'm going to talk through some of the problems on the practice final, as well as discuss the expectations for the final exam. So I sent you a detailed breakdown of all the questions on the final exam. So the way it's going to work is you're going to have 6 problems on the final exam. For 2 of the problems, you're going to get a choice of 2 options. So for 2 of the problems, I'm going to give you 2 different ordinary differential equation problems, and you need to solve one of the 2. And then just submit the one that you solve. So you don't need to solve both of them. You have the choice between the 2 of them. So whichever one you find easier. So on these, there are going to be a total of 4 subproblems. I'm going to pair them up, and then you're going to have to choose one of each 2. So note that on problem 2, you need to solve one of the 2 subproblems for problem 2, and on problem 3, you need to solve one of the 2 subproblems for problem 3. So for example, there are going to be 4 subproblems. One of them is going to be something that you can solve using a separation of variables method. One of them is going to be an inhomogeneous linear ODE with constant coefficients. One's going to be exact differential. One's going to be a first-order linear system. So you will have to do 2 of these 4 things, but you won't know which 2 you can choose. So there is some possibility that I will pair together the separation of variables problem with, say, the exact differential one, or maybe the inhomogeneous one with the linear system, or some other ordering. Will it say what technique is for what question? No, it will not. So you will need to recognize which technique you use for which question. So there will be 4 questions. I will tell you in advance that each one of them will be solvable using one of these 4 techniques, but you will need to recognize and figure out which method to use. Notably, for some of these, I also have some background expectations. So let me just go ahead and tell you that at least on one of these questions, you may need to use integration by parts. On another one of these questions, you will probably have to use the substitution method for integrals. So this was stuff that we studied at the very first week in class. So when I told you that you needed to be fairly quick at these various techniques because they were just going to be basic building blocks and not even questions that are tested on their own. So there will be a question that requires integration by parts. There will be a question that requires a substitution method. I built a question that makes use of partial fractions. I actually, when I was solving it again, like as a test solve, it turns out that there are ways of solving it without partial fractions, but it's depending on how you want to solve it, it may be easier with partial fractions or it might be harder. So make sure that you know how to take all standard derivatives as well. So you need to do things like the product rule, the chain rule, quotient rule, because if I'm asking you to do something like a Taylor series, then you need to take derivatives, obviously. So make sure you know these standard calculus techniques. On problems 2 and 3, you will be asked to solve 2 of these problems. They're going to be paired in groups of 2, and so you should study all these different methods because you won't necessarily know which ones. The purpose of having this option is mostly so that we don't run out of time. And so making you solve all 4 of the questions will probably take too much time for a 2-hour-long exam. So I'm giving you an option of whatever you're more comfortable with. Any questions about that? Note that on any of these 4 problem types, you may be asked to solve them as an initial value problem. In fact, you should expect to solve them as an initial value problem. Most of the questions, most of these 4 will be initial value problems. Okay, we also, in this class, we studied a lot of linear algebra. So on the practice one, we had to do all 4. Yes, so let me go back to the practice exam. So on the practice exam here, what we had is I had these questions 4 and 5 here. So each of these represented a specific type of problem. So you had this problem here, which was one that you could solve using substitution. This one here, which is a higher order linear inhomogeneous equation, which you can solve by using a characteristic polynomial and an ansatz. You had this one, which was an exact differential. And you had this one, which was a first order linear system. Oh, yeah, so the first one here is separation of variables. You said earlier that there will be one that can use the matrix method and one only by substitution. Oh, wait. Wait, did I? So the first order linear system here, I will say that the first order linear system is one that you can solve using either eigendecomposition, or you could solve it by substitution. So on that, if you decide to solve the question that is a first order homogeneous linear system, you will be able to use either the substitution method or eigendecomposition. Oh, can you repeat which one is for 4? So basically 4 and 5 I've combined together, and so you should think of this as 4 different subproblems, and then I'm going to mix and match those two together into 2 pairs. Can you repeat which is which for 4? Yeah, sure. This one here is separation of variables. This one here is the higher order inhomogeneous linear system with constant coefficients. This is the exact differential, and this is the first order linear system. If you want to be able to recognize them, one way of recognizing it, well, if you have 2 different equations, then it's a first order linear system. If I write it out as this dx and dy, that's probably because it's an exact differential. And then for the other 2, hopefully you can recognize that this is a linear system with constant coefficients. And then the remaining one will be one you can solve using separation of variables. Note that I have tried to make all 4 of them about it. Yes, so basically there are a couple different possibilities. One is maybe I combine together, I give you a choice between 1 and 2, and a choice between 3 and 4. So you need to solve 2 of these at the end of the day. Yes, they'll all be worth equal marks. Or maybe, but you don't necessarily know which pairs they'll be. So maybe you have to choose to solve one of 1 or 4, and maybe one of 1 or 2 or 3. They will all be worth equal marks. I have tried to make them all about as time-consuming. So you should keep that in mind, which is that the separation of variables problem isn't necessarily going to be easier than the other ones. So I might have done something like make it a harder integral. So just throwing that out there. Yes, so for each of so you can sort of see this in Crowdmark. So if you go into Crowdmark and go into the sanity check, what I've done is we have all these questions. So you guys can see the questions. I have separated into question 2 part 1 and question 2 part 2. You will need to solve one of these 2. So if you choose to solve part 2, then you'll need to upload it to question 2 part 2. It'll be worth 20 points. If you choose to solve question 2 part 1, it'll be worth 20 points. You will not get extra credit for solving both of them. So you'll choose one of the 2. And then for question 3, you'll choose one of 2 options. Okay, can we get full marks if we solve half of each? No, you cannot. Yes, you leave the other one blank. Actually, well, let me think about it for a moment. Okay, well, I didn't actually write this on there, but if you solve both of them, I will give you the higher of your 2 marks. So if you end up having a lot of extra time, if you solve both of them, I will give you the higher of the 2 marks. But you only need to solve one of them because you get the higher of the 2 marks. Well, let's do it that way. So if you end up having extra time in your 2-hour-long exam, one thing that you could do is you could go back and solve the other one of them of the pair. And this might be helpful in case you messed up on the first one. But no, if you get half of the credit, if you get 10 points on each of them, then your overall mark is only going to be 10 for question 2. Any other questions about that? So that is question 2 and 3. So basically, a couple of you mentioned to me that it turns out that looking at the previous year's exams, those are all 3-hour-long exams. This is a 2-hour-long exam. So I had to figure out ways of shortening this exam while still testing roughly the same material. So this is one of the solutions I came up with, basically. It's a little bit complicated, but basically you get a choice. So you get to choose between a couple different problems twice. And you only need to solve one of them. Why is yours only 2 hours long? Because I made a mistake, and I didn't request a 3-hour-long exam. So this is completely my fault, and you should absolutely blame me for it. Which is why this is also shorter. So if if this were a 3-hour long exam, I would just make you do all of these problems. Um, but it is a 2-hour long exam, and that's because I made a mistake, and yeah. And you shouldn't be punished for my mistake, and so I had to come up with this. Since you have less time, you'll be marking it easier and curving the marks? No. You have less time, and so I made the exam shorter. So that's basically how I did it. So the exam is shorter than it would be otherwise, but you will still be marked similarly. Okay, so let's go on to some of the other problems. So problem 1 is a little bit more straightforward, and it will look almost exactly like the question in the practice final. Obviously, it's going to be a different set of numbers, etc. So I am going to give you a diagram. So you need to figure out from a diagram how to write a matrix. So if I give you a Leslie diagram, you need to be able to write down this matrix. So just as a reminder, when you have an arrow going from the first column corresponds to whichever the first stage of life is, and then you need to, all the arrows coming out from it correspond to the values in that first column, and so on. Okay, so you need to be able to write down a Leslie matrix. You need to be able, yes, this will be on YouTube. I will put this on YouTube at least for the next week. I might take it off later since this feels like a weird sort of lecture to put on YouTube. But yes, I will put all this lecture on YouTube, this part on YouTube, so that you can go back to this. Yeah, so you need to write down a Leslie matrix. You take each of these arrows and, okay, so for a Leslie matrix, you need to order it first, 1, 2, 3, and then in the first column, that is all the arrows coming out of the first node. So the first node goes from H to J, so from 1 to 2. So, and you don't have any other arrows coming out of H. So then that, you don't have any arrows from H to itself, and so that's a 0. You don't have any arrows from H to A, and so that's a 0. You do have an arrow from H to J, and so that's 0.2. For the J here, for the second column, you have an arrow going from J to A, which is 1, and an arrow from J to H, which is 1. And so therefore, but no arrow from J to itself. And so you have a 1, 0, 1. For the last column, you have a 2 from A to H, so that's a 2 here. You have an arrow from A to itself, so that's 0.5, and you don't have an arrow from A to J. Okay, so you need to write down a Leslie matrix. You need to figure out what the population is. Yeah. Oh, I'm sorry. Yeah. So you need to figure out what the population is in the future. So the way you'll do this is because you have this Leslie matrix, you take this population, you put it into a vector, and you multiply. If you multiply it once, you get 1 year into the future. If you multiply it twice, you get 2 years into the future. So this is the linear algebra portion of the class, and so there's just matrix multiplication. So we'll get the model, and we just write the matrix. Can it be the other way around in the final? I will give you the diagram, and you will write the matrix. In theory, you should know how to do it both ways. It's just like which arrows go where. But in the final, it will be going from the diagram to the matrix. For part 3, can you use the inverse of the Leslie matrix or a system of equations? For part 3, you can use either. So as Jordan mentions, you can use the inverse to go backward to do the backwards multiplication, or you can solve a system of equations to go backwards. So you can use either method. Often it is faster to use something like a system of linear equations and Gaussian elimination, or like substitution methods or whatever. So you can do the full Gaussian elimination. You can also just solve the system of equations. You just need to somehow solve the system of equations. You can either do it within, there are many different ways of doing it, including matrix inverses. So whichever one you're most comfortable with. Okay, so that's problem 1 on the final. So that is a linear algebra problem. Problem 2 is this ordinary differential equation thing. So it will be, is an ordinary differential equation set that we've discussed in detail. Problem 4 is a qualitative analysis. So this has 2 different parts. One is you're going to have a multivariable function, and you're going to find the critical points, and then figure out the mins, maxes, and saddle points. The second part is going to be given an autonomous nonlinear ODE system, find the coordinates of the real equilibria, classify them, and determine their stability. And I am personally going to recommend that you use the eigenvalue method rather than the d-test. You can use Euler, and it will still work, but it will turn out that the eigenvalues that let's just say that the two parts of the problem are very closely related. And if you go back to the solutions here, for the multivariable critical point, what you need to do is you need to construct a matrix. Just a moment. What happened here? So the first thing you need to do was you need to found the critical points of. There will be partial marks. So you should write down your work as well as label your work so that it's easier for us to give you partial marks. I will be writing out a detailed grading rubric for the TAs that includes partial marks. Though for some of the problems, it's harder to give partial marks than others, obviously. But yeah, so for the multivariable critical points, to find the critical points, you set the two partial derivatives equal to 0, and then you find the critical points. For the nonlinear system of equations, you set the two equations equal to 0, and then you find the critical points. For the multivariable critical points, then to figure out their behavior. Oh, yes, I can release quiz 5 solutions. I'll do that right after class today. Yeah. To figure out the behavior classified as saddle points, you can either use the d-test or you can look at the eigenvalues of the Hessian. So you can use, I personally prefer the eigenvalues of the Hessian. The Hessian is going to have all these partial derivatives. You find the eigenvalues, and then if they're opposite sign, you get saddle points. If they're both positive, you get a relative min. If they're both negative, you get a relative max. For the nonlinear system, you get the Jacobian matrix, which is going to do the partial derivatives of each of these functions with respect to x and y. And then you look at the eigenvalues, and that tells you the classification. Okay, so that's problem 4 on the exam. We have a question. On part 3 of problem 1, is the 0.5, 0.5 on the third row looking into the population? Oh, it is quite possible I made a mistake on the solutions guide, but let me look to see. So on part 3 of problem 1, estimate the population in a year. Oh, wait a moment. Oh, baller. What happened? Oh, what happened was I wrote down the matrix incorrectly here. The matrix is actually, it's the same matrix. So yeah, this is a typo. Sorry about that. I might have messed up this one as well. I'm not actually sure. But yeah, so this is a typo. It's the same matrix that you use again. Yeah, so let's keep on going. Part 5 is a power series. And in fact, this is slightly more complicated because on the exam than on the practice exam, just because of the problem I chose. So what will happen is I will give you some function, and then I will ask you to find a cubic approximation using the first 4 terms of its Maclaurin series. There are a couple different ways of doing this. One way, which is the long way, but will always work, well, just about all, I mean, by definition it will always work, which is you can take take each of the derivatives at 0 and plug it into this formula. This will be really painful for the problem on the final, but you can do this. So this will always work. And you do have enough time, so you can do it in the amount of time you have, but it will just take longer. So this is the hard direct method of finding these Taylor series. The other way of doing it is you can also, I will give you a hint. So it will have some particular form. I won't tell you which form it is. I will give you a hint for the Taylor series of a particular function. So it won't be e to the x. It'll be some other function, one we may have seen. We can use a calculator for... Oh, no, you're not allowed to use a calculator for anything. Sorry about that. For question 1, I have constructed the numbers so that they are easy to do. Yeah. So the calculators are not allowed in this for this final, unfortunately. I mean, I don't want to say unfortunately. It's just not what we're testing. On the practice, yeah. So I have made the numbers easier to work out on the actual exam. So that's something I spent quite a bit of time trying to work out, was making sure the numbers all worked out nicely, so you don't need to use a calculator. Let's see. So for the cubic approximation here, Yeah, so another way of doing it is you can do manipulations of this function. So if in this case, you would substitute in x squared wherever you see x into this, and that gives you this equation, and you add x cubed to it. So if we can do the plugging in method, we won't need to take the derivatives. Yes, but it will be a little bit more complicated. So there are a couple other things you might do. So for example, let me actually do this in. So let me go over OneNote. And so will the power series be a version of, yes, the power series will be one of the ones that you saw in class. So the power series will either be 1 over 1 minus x, e to the x, cosine x, or sine of x. But now there are a couple of different operations that you need to be a little bit careful of, which is, for example, I might ask you something crazy. Like I might ask you, what's the power series of, let's say, x e to the x. So that would be, so if e to the x is equal to 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, etc., then x e to the x would be equal to x plus x squared plus x cubed over 2 factorial plus x to the fourth over 3 factorial plus x to the fifth, sorry, I got the numbers wrong, x cubed over, no, I got the numbers right, x to the fourth and x to the fifth over 4 factorial, etc. Okay, so you can do things like that, and you can even do things like this. So if I wanted to know the derivative of x e to the x, that's going to be equal to 1 plus 2x plus 3x squared over 2 factorial plus 4x cubed over 3 factorial plus 5x to the fourth over 4 factorial, etc. Okay? And so this means that this is also equal to x e to the x plus e to the x. Okay, so I might ask you to do manipulations like that, or I might ask you to do manipulations like e to the x divided by 1 minus x. Well, what is the power series for this? Well, this is two different power series. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the fourth over 4 factorial, etc. times, oh, how is the derivative equal to x e to the x? Oh, product rule. So x times the derivative of e to the x, and e to the x times the derivative of x. So this is the product rule. Okay. So another thing I might ask you to do is I might ask you to multiply the other power series. So if you had 1 plus x squared plus x cubed plus x to the fourth, etc., you only need, when you're multiplying together power series, if I'm asking you to do an approximation, you only need to keep in mind the ones that correspond to each other. So how many different ways are there for me to get x? So this is equal to this thing, 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 times 1 plus 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 times x plus 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot 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 times x squared, etc. And so on. And if you combine these things together, if I only care about the cubic terms, this is going to, we only need to worry about 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x squared plus x cubed over 3 factorial plus x squared plus x cubed plus, oh sorry, that's 2 factorial plus x to the fourth. And so that would give you the Taylor series for those two things multiplied together. Because you're only keeping, oh sorry, not x to the fourth, x cubed. So you can add those things together and it gives you a multiplication of two power series. So the problem on the exam, I won't tell you exactly what it is, but it will be one where you can solve it a couple of different ways. Oh, so suppose I give you this formula here. Suppose I ask you for the power series of this thing. there are a couple different ways you can find this power series. One of the ways of finding this power series is to take the derivative of this, to take the derivative of x e to the x. And so if you take this derivative, then that's one way of finding that power series. Does that make sense? Oh, you have to recognize. So basically, you can recognize it as an basically as an integration problem. If you recognize that one thing is a derivative of something else, then you can do that. So for example, let's see, what's another good one? Let's say I had the e to the 2x. So e to the 2x, there are a couple of different, what's a good example here? Okay, so one thing is, if you can recognize something as equal to a derivative, then you can also just take the derivative of each of the terms of the power series. How do we know to do the first term? Another way of doing it, no, you should take the derivative of every single term. So here, okay, let me give myself some more space and write this out. Oops. So for example, if I gave you x e to the x plus e to the x, there are many different ways of solving this power series. One of them is we know that this is equal, we know what this is equal to, and we know what this is equal to. So that's one way of doing it. But another way of doing it is if you recognize this as equal to the derivative of x e to the x, then there's an easier way of doing it, which is you just take this thing here, this is the derivative of x plus x squared plus x cubed over 2 factorial plus x to the 4th over 3 factorial plus x to the 5th over 4 factorial, and so on. And you can just take the derivative of each of the pieces, so that's 1 plus 2x plus 3x squared over 2 factorial plus 4x cubed over 3 factorial plus 5x to the 4th over 4 factorial. Oh, if I have f of x is equal to x e to the x, then f prime of x is equal to x times the derivative, by the product rule, x times e to the x plus e to the x times 1, which is equal to x e to the x plus e to the x. So remember, this is the product rule from MATA35. The product rule says that if f of x is equal to g of x times h of x, then f prime of x is equal to g of x times h prime of x plus g prime of x times h of x. Okay, so basically there are all these different manipulations you can do. You can multiply together power series. You can take derivatives of power series. What's the quotient rule again? The quotient rule, which you should also know, is if f of x is equal to, let's say, g of x divided by h of x, then f prime of x is equal to the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. Oh, there. So these are all just standard derivative things from A29, which you will be expected to know. And of course, the product rule, as we discussed in the very first couple of weeks, is also related to integration by parts. What's h prime of x? Oh, sorry, h. I wrote these in the bad way. G of x times h prime of x. Yeah, there. Okay, so I'm just going to say there's going to be a lot of manipulations. If all else fails, you can always just use the time-consuming method of just taking all the derivatives. I will go ahead and tell you that there are going to be at least three different ways of solving the power series on the exam. One way is for you to multiply together two power series. Another way is to take the derivative of a power series that I will give you. So let me just tell that to you in advance. And another way is to do it by the direct method. So just be aware of that. Any of those three will work, so you don't need to know all three of them. Okay, and let's see. We already discussed. Let's see. We had one final problem, which is an epidemiology problem. The epidemiology problem will not be one of the super complicated ones that we've been discussing today. Instead, it will look more like it'll be a phase line problem, basically. So it'll be something that you can convert into a one variable system because it's a two compartment model with a fixed population size. And so for that, what you'll need to do is you'll need to let me make this smaller a bit. You'll need to draw a two compartment model. You need to convert it into a one compartment model. You need to find the equilibrium values by setting s dot and I dot equal to 0, or just setting I dot equal to 0 since you're converting it into a one variable system. And then you need to classify the equilibria by type and stability. And then you need to describe in words a little bit what's the long-term behavior of the system. And that is the entirety of your final exam. Can you go over how you determine stability? I kept getting the opposite. Oh, wait, did I do that wrong? I hope I didn't do that wrong. So I dot here is equal to minus 0.001 I squared minus 0.15 I, right? So suppose I is really, really, really big. So if I is, say, 1 million, then you're going to be subtracting some really, really big number, right? So if you're subtracting some really, really big number, then the arrows are going to be pointing inward, right? Suppose you have some number that's really, really small. Sorry, that's just negative. If you have a negative number, well, an I is negative, it's probably so an I is going to be negative, and this minus. Yes, I will have office hours on Friday. I will absolutely have office hours on Friday. So I is going to be negative, and your I squared here is also going to be, I squared is going to be positive, so you're subtracting that, so that's going to be negative. So if it's less than 0, you also have an arrow pointing downward. And if you plug in the number between 0 and 85, you'll find that you end up getting a positive number, and so that arrow is pointing upward. If the arrows point inward, then you have something that's asymptotically stable. If they point outward, it's unstable. If the arrows both point in the same direction on either side of the equilibrium, then it's semi-stable. Any other questions? I also have office hours right now, which I'm happy to continue answering questions for those of you who are around. I will have office hours on Friday at the usual time for office hours. So that will be, if you multiply a power series, how do you multiply a factorial? Oh, yeah, that's a good point. How do you multiply a factorial? Well, the answer to that is, just a moment. 2 factorial times 3 factorial is equal to 1 times 2 times 1 times 2 times 3, which is equal to 2 times 2 times 3, which is equal to 12. Do you have tutorials this week? Yes, you do. Very good question. If it's semi-stable at 0, but approaching 0 on the real side, would it be asymptotically stable? So, Ken just asked the question, if you have something that looks like this, is it asymptotically stable? So, The answer is you need to be a little bit careful about what you're saying. I assume you meant if it's approaching it on the positive side, not on the real side, because this is the entire real line. So this here is mathematically semi-stable. But in practice, it is asymptotically stable for the positive, for positive numbers. So there, if I ask you what it is mathematically, you would have to answer semi-stable. But then if I ask you what's the long-term behavior of the system, you would say that 0 is asymptotically stable and everything goes to 0. Does that answer your question? Okay, let's see. Yeah, like I said, we're starting office hours right now. I'm just going to continue answering questions until people leave or feel comfortable. Yep. Yeah, so you still have tutorial today, and I messed up the numbers on the quiz 5 word problem. Will the epidemiology have as many numbers as in quiz 5? The epidemiology problem will look very, very much like the problem on the practice final. So I will leave it at that. Similar or very similar? It's pretty similar. I mean, you should in theory know everything that's in this class, but I wrote the study guide after I wrote the final. So this is me writing down the study guide after I've written the final, and I am telling you the techniques that went through my head as I was as I was writing each of the problems on the final exam. Having said that, you still need to know all the basics. So, for example, things like this is why I included this section here afterwards, because I realized that like, for example, when I'm solving this problem, this is a separation of I have one problem that's a separation of variables problem. In my head, that's just a separation of variables problem. But then after looking at it, or looking at some of these problems, I was like, oh, wait a moment. You guys might also need to brush up on your integration and derivatives. So, but yeah, so if you like, this is all the problems on the final. And if you can do each of the things I list on here, you will do fine on the exam. If you, this is basically all the things that you should be able to do having taken this class. Yeah, so like if you think about classes in terms of learning objectives, these are the learning objectives for this class, and they're also exactly what I'm testing on this final. Well, I mean, I guess there was one other learning objective, which is I made you guys do like some Python in quiz 3, which I'm obviously not doing on the final. But yeah, these are basically all the non-computer based learning objectives. Could you go over how to solve equilibrium values for the last question in quiz 5? I think I computed my equations correctly, but I got confused when solving the equilibrium. Yeah, sure. Let me pull up quiz 5. Let's see. Just a moment. Quiz 5. Wait a moment. Where is quiz 5? Give me a moment. Let me find it again. Okay, so This is quiz 5. And we had which problem? The equilibrium values problem. Yeah, so this was the word problem, right? Problem 4? Yeah, so this was slightly more complicated because you had to keep in mind how many different gallons of things there were in each case. So let me rewrite down some of the problems here in OneNote. So we had tank A, which was 100 gallons. We had tank B, which was 200 gallons, and 50 pounds of salt to begin. Salt initially. So from A to B, actually let me draw these not as squares. Let me draw these as tanks. Just make it clear, this is not quite the compartments we're going to be working with. So this is tank A. Tank B is bigger than tank A. So this is 100 gallons. Tank B is 200 gallons. Oh, for some reason my drawing is behind me. Okay, so there's a little bit of a delay here, but hopefully it's all still coming out. Come on, you can do it. Okay, so you have 100 gallons and you have 200 gallons for the other one. And then we have arrows, right? So water is pumped from tank A to tank B at 10 gallons per minute. So 10 gallons per minute. And then the water is pumped from tank B to tank A at 5 gallons per minute. And water is drained from tank B to the outside world at 5 gallons per minute. Okay? And we're assuming that everything's perfectly mixed. So now the question is, how much salt is being pumped from one to the other? So if you draw this as a compartmentalized model, so what is this arrow here going to be? Well, that arrow there is going to be 10 gallons per minute, which is 1/10 of the total amount of stuff in A. So this is going to be 0.1A, because it's 10 divided by 100. How much is pumped back? Well, that's 5 divided by 200 that's pumped back. That's equal to 0.025 B. And here we also have 5 gallons that are pumped out, so that's 0.025 B. So then we have A dot is going to be equal to, well, how much is it losing? It's losing 0.1A. How much is it gaining? Plus 0.025 B. How much is B dot gaining? B dot is gaining 0.1A. How much is it losing? Well, it's losing both of the arrows that are leaving, so that's 0.05 B. Oh, we also have pure water being added, so sorry. We also have 10 gallons per minute pure. But if it's pure water, then that means there's no salt, and so we can just say this is 0, which is why I didn't include that. Oh, sorry, that's 5 gallons per minute. That's refilling. But it doesn't really matter, because you're refilling it with pure water, and pure water doesn't have any salt, and we're just measuring the amount of salt, right? So we don't actually care about that. And so this gives us this system of equations, and then what you do is you set both of these equal to 0, and then you solve. And when you solve, you end up finding that A is equal to 0 and B is equal to 0, because I think on both quizzes I made A and B both equal to 0 for this. Did I do that? Let's see, on my Thursday quiz. Yeah, on both of the quizzes, A and B are just equal to 0. So these were the two respective diagrams. I think the thing I changed was the rates or something like that. Oh yeah, could I go over how I solved it? Yes. So, going back to our OneNote. So when you solve this, what you end up getting is if I add these two equations together, so minus 0.1a plus 0.025b is equal to 0, and 0.1a minus 0.05b is equal to 0. Let me add these two together. You get minus 0.025b is equal to 0. So therefore, b is equal to 0. But if b is equal to 0, then that implies that minus 0.1a plus 0 is equal to 0, which implies that 0.1a is equal to 0, which implies that a is equal to 0. Yep. Yeah, so you just do need to, it's just a system of equations. So you can, if you wanted to, you could have solved that using Gaussian elimination as well. Like you could draw out your matrices, what would that be? Minus 0.1, 0.025, 0, 0.1, minus 0.05, 0, and then you convert this. Clarification. Missed quiz 3, the take-home exam, take-home quiz. So whatever you get on the final, you will also get for quiz 3. Yes, yeah. So the final exam is worth 40% of your mark, but if you do better on your final than on your worst scoring quiz, then you will replace the mark on your worst scoring quiz with your mark on the final. Yeah, so if you got a 0 on any of one of your quizzes, then effectively the final is 50% instead of 40%. But if you did really well on the quizzes, then the final might only be worth 40% for you. Any other questions, or? Okay, yeah, and like I said, I will have office hours on Friday at the usual time. Oh, wait, let's see. Yeah, so I will send out another email about like what time my office hours are on Friday. I haven't decided if they'll be during the regular class time or during the after class time. If you have strong opinions on that, send me a note. But I'll send out an email announcement with when my office hours are on Friday. You still have your tutorials, which will all just be review, obviously. Yeah, there's no class on Friday. This is your last class, so you guys are done. You just need to survive until like the final. So, but yeah. So yeah. Bye everyone. If I don't see you in office hours, then I will see you on Monday. So make sure you study. The exam is not easy. I've shortened it, but it's still not an easy exam. So good luck. Please ask me questions on Piazza and during office hours if you still have any. Yeah. Let's see. Anything else? Or if there aren't any more questions, then I will go ahead and stop recording and see you all later.